Welcome to the first homework video. We'll be releasing videos like this one every week to give you an introduction to each week's homework, go over some code, and give you a reference for what your solution should look like. I also want to remind everyone to download and complete the tasks in the lab write-up this week. It has useful tutorials for JavaScript and Three.js, and how to effectively debug JavaScript using the Chrome developer tools. In this week's homework, you'll start getting your toes wet with the graphics pipeline that has been discussed in lecture, specifically the model, view, and projection matrices. Once you've completed each part of the assignment, you'll have a fully functioning implementation like the one in this video. You can compare your implementations of each part to what you see here. Across the top, you'll see various buttons. Activating these buttons will map your mouse movements to different variables as described in the homework write-up. You can see these variables updating in the text at the top center. When model control is activated, mouse movements will change the model matrix parameters as you'll implement in section 2.1.2. Just dragging your mouse will rotate the teapots around the X and Y axes. Dragging the mouse to the right will rotate the teapots around the Y axis like this. Dragging it up will rotate them around the X axis like this. When debugging your rotations, you might find it useful to see a different viewpoint of the teapots. Hit space to toggle a top-down view. Dragging your mouse while holding the Shift key in the model control mode will translate the teapots along the X and Y axes like this. Holding the Control or Command key will translate the teapots along the Z axis like so. You'll implement this functionality in section 2.1.1. When the viewer position mode is activated, dragging your mouse will update the viewer position vector, as you'll implement in section 2.2.1. Dragging it horizontally will translate the viewer's position along the x-axis, while dragging it vertically will translate the viewer's position along the y-axis. When the Control or Command key is pressed, the viewer's position will be translated along the z-axis like so. When the viewer target mode is activated, your mouse movements will update the viewer target vector as you'll implement in section 2.2.2. Once again, horizontal mouse movements move the viewer target along the x-axis, vertical movements move the target along the y-axis, and when the Shift key is pressed, vertical mouse movements move the viewer target along the z-axis. In the last part of the programming assignment, section 2.3.1, you'll map the mouse movements to the near clipping plane parameter, and we'll see that dragging the mouse vertically will change the distance to the near clipping plane, making certain objects disappear. In section 2.3, you'll implement both the perspective and orthographic projection transforms, which you'll be able to toggle between by pressing the perspective or orthographic matrix button. That's all for this week. Good luck, and make sure you come to office hours or post on Piazza if you have any questions.